Hi, it's Sir Rob. Today, I am going to discuss the second chapter of our course Management Science. This chapter focuses on the power of prescriptive analytics in business transformation and the factors that enable a successful implementation of prescriptive analytics projects. In today's dynamic and data-driven world, successful businesses are not merely reactive. They are proactive, forward-thinking, and strategic. While descriptive and predictive analytics help organizations understand what has happened and what might happen, it is prescriptive analytics that empowers them to make optimal decisions in real time. It is the pinnacle of data analytics, where insight meets action. Prescriptive analytics transforms raw data into powerful, actionable strategies by leveraging advanced algorithms, machine learning, and optimization models. Whether it's streamlining supply chains, personalizing customer experiences, allocating resources efficiently, or minimizing financial risks, prescriptive analytics guides businesses toward the best possible outcomes. As always, in the practice of accountancy, we should remember to be professional, perform effectively and efficiently, follow standards, and document our work adequately and properly. In this chapter, we delve into the practical dimensions of prescriptive analytics, beginning with its common areas of application across various industries. From streamlining supply chains and optimizing workforce deployment to improving financial forecasting and enhancing customer engagement, prescriptive analytics is at the forefront of strategic decision-making in today's data-driven business landscape. To bring these concepts to life, we will explore real-world case studies that illustrate how organizations successfully implement prescriptive models with artificial intelligence to solve complex problems and gain competitive advantage. These cases not only demonstrate theoretical concepts, but also highlight the tangible impact of data-backed recommendations. Finally, we will unpack the 5 pillars of prescriptive analytics, the foundational elements that support its effectiveness. These include hybrid data management, predictive and prescriptive application integration, prescription side effects, adaptive algorithms, and feedback mechanism. Understanding these pillars equips us with a structured framework for analyzing business challenges and delivering the most effective solutions possible. This chapter aims to bridge insight and action, transforming data into smart, strategic decisions. And on with our first topic, common areas of application.
Some of the areas where prescriptive analytics is currently providing optimization benefits are: 1. Marketing. It is in this area that saw the earliest applications of prescriptive analytics. Predictive analytics uses data models, statistics, and machine learning to predict future events. In marketing, this can be used to make better decisions regarding media planning and buying. Using this tool, marketers can gain a better understanding of which campaigns are working and what sorts of advertising will lead to an increase in sales in future. There are several ways that marketers can incorporate predictive marketing analytics into campaigns to improve effectiveness and enhance marketing. 1. Understand consumer behavior. The insights give marketers an understanding of consumer interests based on past interactions. Marketers can segment audiences based on known interests and demographic information. This better equips marketers to serve individuals with targeted messaging at the right time on the right device. Ultimately, this helps break through constant ad noise, improving consumer experience and brand loyalty. 2. Optimize resources and spend. Marketers can determine where to focus advertisement spending based on the value the customer presents. Predictive data identifies the advertising channels and times that warrant increased marketing spend and resources, as well as where to reduce investments. For example, data for an ice cream brand would likely indicate that marketing efforts in northern temperate areas will yield better results in the summertime, allowing them to save the bulk of the ad spend for summer months. 3. Qualify and prioritize leads. Predictive analytics also allows marketers to qualify and prioritize leads. Insight into consumer behavior allows marketers to identify ideal audience segments that are closer to conversion. These analytics demonstrate how likely a consumer is to act, allowing marketing teams to devote more attention to those consumers and minimize wasted ad dollars on consumers that will not respond to marketing. For retained customers, finally, predictive analytics assist in customer retention efforts as marketers are able to better understand consumers' needs. This helps with product and service offerings that complement consumer purchase history and interests, and also sheds light on cross-sell and upsell opportunities that are not worth exploring. Data insights in marketing should also provide answers and action options to questions such as: what do customers want? How much cost did we acquire them? How can I acquire more customers like them? Which customers are the most loyal? How long will they stay with us? Businesses reduce cost of running the business by interacting with their customers and improve profit, so prescriptive analytics options should provide insight on what interactions make their customers loyal. 2. Healthcare. This is an emerging area for prescriptive analytics. The healthcare industry is under pressure to deliver better outcomes due to increasing consumer demand. This pressure is coming from many directions, including a shortage of primary care physicians, the pervasiveness of chronic illnesses, and the increased cost of healthcare. In response to this pressure, many healthcare providers and insurers are moving from a volume-based business model to a value-based business model. This shift improves outcomes by making healthcare more efficient and effective. However, it also creates new challenges for healthcare professionals who must now be more productive and efficient in their work. The extreme pressure to do more with less makes a case for a new approach to healthcare operations. The healthcare industry can use prescriptive analytics to recommend patients or providers' best course of action. It can also compare multiple what-if scenarios. For example, if a healthcare provider is considering adding a new service, prescriptive analytics can assess the impact of choosing one service over another. With it, healthcare decision makers can optimize business outcomes and make more informed decisions about patient care. In a hypothetical example, a health insurer uses predictive analytics to spot a pattern in its claims data. The previous year shows a significant portion of its diabetic patient population also suffers from retinopathy. The insurer then estimates the probability of an increase in ophthalmology claims during the next plan year. Prescriptive analytics can model the cost impact if average ophthalmology reimbursement rates increase, decrease, or remain the same for the following year. It can then recommend a course of action. This type of analytics can be beneficial for insurance companies in predicting trends and planning for the future. The early adopters of big data analytics are doing great things for patient care and their financial health. For example, predictive risk scores help prevent suicides and increase watchfulness in the ICU unit. In addition, gene expression tests allow doctors to identify high-risk people and provide new hope by discovering targeted treatments. Cognitive computing engines, natural language processing, and free text analytics have the potential to help providers pinpoint diagnoses that might otherwise elude them. These tools also provide population health management capabilities for payers and healthcare professionals to highlight those most at risk of being readmitted or developing costly chronic diseases in their care populations. Predictive analytics may be complicated, but healthcare organizations across the country are using predictive analytics to improve patient care and save lives. Data insights in healthcare should also provide answers and action options to questions such as: what's the best way we can maximize outcomes for patients? How can we change processes and maximize interactions with patients? Which patient should healthcare providers intervene with in order not just to do patient management once the patient gets sick, but to do disease prevention, saving patients from getting sick altogether? Another problem it should provide options to solve is how to manage disease once the patient gets them and figuring out how to get involved early, such as the recent COVID-19 disease. 3. Operations. prescriptive analysis supports decision-making relating to manufacturing and logistics, optimizing a company's supply chain. The main applications of prescriptive analysis to the supply chain include consumer trend forecasting. Prescriptive analytics can make deductions regarding consumers' intentions and predict demand patterns to make the right decisions. Calculating consumer trends lets you establish optimal inventory levels to satisfy demand, prevent stockouts, and avoid overstock. 2. Promotion of product traceability. Prescriptive knowledge facilitates real-time information on products, i.e. traceability, at any point across the supply chain, for example, their location, transport conditions, and the logistics and manufacturing processes they've been through. 3. Greater control over supply chain information. Prescriptive analytics paves the way for real-time inventory management, enabling organizations to issue instant supply orders and accurately track their goods, among other advantages. The McKinsey publication, in an article titled "A More Resilient Supply Chain from Optimized Operations Planning," explains how prescriptive analytics can benefit companies. Quote, "Optimization in operations planning involves determining the optimal choices for a set of decisions in a given business environment and business target. This type of optimization generally works best with prescriptive models that provide the ideal set of decisions as an output." Unquote. In today's changing, competitive market, consumer trends can lead to supply chain disruption. Against this backdrop, prescriptive analytics has become an ally, helping companies to stand out as leaders in their markets. In the past, organizations used their know-how and experience to make rough estimates, with varying degrees of success, on sales and the product quantities needed to meet demand. Nowadays, prescriptive analytics is a technological solution to anticipate future logistics scenarios and make decisions based on data analysis. E-commerce giant Amazon recently announced that it would be shipping the products even before the customer buys it. Strange. How can Amazon know who would buy which product at what time? Amazon uses predictive analytics blended with descriptive analytics, trends, patterns, exceptions of customers' historical shopping data to predict the probability of a customer to buy a product with the date-time information. The system prescribes Amazon to ship the product to the customer with an expected order date. Amazon then packages and dispatches the product to a local warehouse until a real order has arrived. As soon as the order arrives, the product is delivered to the customer almost instantaneously. Many other players also use analytics for customer experience management, including Flipkart, eBay, MacMeTrip, Big Rock, Home Shop 18, etc. Data insights in operations should also provide answers and action options to questions such as: how do we better anticipate demands at any given time? How do we maintain the quality of the product in relation to cost given that the quantity of material and labor vary over time? How do we figure out ahead of time that a certain product is likely to fail and fix the product before it does fail, so we can maximize the uptime? 4. Human resources. In HR, this is known as workforce analytics. Workforce analytics refers to gathering HR data, understanding what it means within the context of business goals, and using it to optimize decision-making and operations. Historically, this process required several teams and a lot of time. But modern analytics technology has simplified an employer's ability to create and use meaningful data. Why are workforce analytics important? Workforce analytics helps employers identify potential causes of performance-related problems and address them in ways that maximize opportunities and minimize risk. Without this data, employers may have limited tools or no tools to support strategic decisions. Consider employers that want to reduce the cost of overtime resulting from unplanned absences. They can use advanced analytics to compare overtime rates against absences and look for trends. They may also conduct a root cause analysis to understand whether the unplanned absences are connected to specific teams or supervisors. This information can then be used to develop an appropriate corrective action. Manager and employee training, for example, may help improve attendance and scheduling management and engagement. What are other benefits of workforce analytics? Workforce and HR analytics that are easy to understand and act upon can potentially help businesses achieve strategic objectives. Specifically, employers may be able to use analytics to make more timely and appropriate decisions. Leveraging internal and external data may help employers anticipate what could happen to their organization and quickly address or mitigate potential risks. Recruit the right talent and keep them engaged. With advanced analytics, HR professionals can potentially identify the type of talent needed for a particular job. The data can also help employers ensure that employees remain motivated to fulfill the company's mission. Improve productivity. Centralized, real-time workforce metrics allow employers to monitor employee productivity and adjust operations as needed. Reduce costs. Employers that have access to benchmarks for their industry and location may be able to recruit employees with competitive market rate pay rates. Once hired, analytics can be used to monitor scheduling and help control overtime costs. Enhance data security. Workforce analytics that are cloud-based typically have a flexible and resilient infrastructure designed to help protect sensitive employee data and reduce risk. Given these benefits, companies should ideally be eager to early adopt and explore how prescriptive analytics could transform their HR functions. Analytics in HR should also ideally provide answers to the following questions. How do we best reward our outstanding employees? How to keep the morale of the employees high even in times of recession? What recruits should we hire? Shall we dole out overtime or not? If yes, how much overtime is beneficial to the company and the employees? 5. Insurance and risks. Data and analytics have driven pricing and claims-related business decisions for decades. Now, with the proliferation of big data, more and more insurance companies are mining and using this data to predict what will happen to their businesses in the future and to drive decisions that will positively affect these outcomes. In 2021, insurance companies invested $3.6 billion in big data analytics. In return, they've seen a 30% increase in efficiency, 40 to 70% cost savings, and a 60% increase in fraud detection rates. The insurance industry is a leader in the use of big data analytics and now uses this information at almost every stage of its everyday operations. While insurance analytics can improve the efficiency of claims, policy, and sales processes, that's just the tip of the iceberg. Other key benefits of data analytics for insurance include 1. Lead generation. Analysis gives marketers and insurers a clear understanding of their customer acquisition cost, or CAC, displaying how much is spent on organic lead generation and third-party vendors. The end result of this is that it puts out a clear view of where companies should invest their resources. 2. Better customer satisfaction. Companies that accurately predict their customers' needs, whether it's support or a particular product, are more likely to exceed expectations and reap the rewards. 3. Less fraud. Claims fraud has always been one of the biggest challenges facing the insurance industry. In the United States alone, fraudulent claims cost at least $80 billion per year, an estimated 10% of all payouts. Data analytics in insurance makes fraud detection processes faster and more accurate. Analytics make it easier to spot trends, while advanced analytics and predictive modeling use historical data, for example, past claims, frequency of claims, and externally sourced information, for example, credit scores, to flag claims with a high probability of being fraudulent. These data analytics have become so advanced that some predictive analysis models can even pinpoint customers who are most likely to submit fraudulent claims, empowering insurers to take preventative measures before they're taken for a ride. 4. Faster underwriting. Data analytics for insurance is eliminating intuition and guesswork in underwriting by using predictive trend data to produce comprehensive risk assessments. These assessments reduce the time burden of manually assessing risk profiles while improving underwriters' ability to set premiums that accurately reflect each policyholder's level of risk. 5. Business growth. The intelligent and ongoing use of data analytics should culminate in business growth. Targeted marketing messages, better customer satisfaction, less fraud, and faster underwriting can only translate into improved revenue. By selling more effectively, cutting fraud-related costs, and improving risk assessment, companies that choose to harness the power of insurance data analytics improve their bottom line. Predictive analytics, in particular, can help companies identify money pits and mitigate them before they get out of hand. From the pandemic to climate change, customers face heightened uncertainty about their safety and well-being. They also question whether their data will be used responsibly, but they are willing to share it in exchange for value. The use of customer data to generate relevant, real-time usage and behavior-based offers that help customers mitigate, manage, and recover from loss can help insurers build trust with customers. That's the value advanced data analytics can deliver both to the insurance customer and to the insurer. Data analytics in insurance and risk should also ideally provide answers to the following questions. Can we detect fraud and non-compliance? Are these customers good credit risks? Can I forecast expected revenue? Can I better price my insurance products? 6. Oil industry through fracking. In the past years, fracking has taken an enormous flight, especially in the United States. In 2013 alone, $31 billion was spent on suboptimal frac stages across 26,100 U.S. wells. In order to know where to frac, make the process safer, and to optimize the fracking process, massive data sets up to petabytes of data are required. Datasets such as sounds of fracking and drilling, images seismic, well logs, videos, cameras monitoring the fracking, and sensors measuring all kinds of variables. Text documents, notes by drillers, and other kinds of data have to be analyzed in real time to recommend the most optimal fracking location and process in order to have the best result. Prescriptive analytics substantially reduces the financial risk of fracking by revealing key insights, modeling potential drilling scenarios, and identifying areas of opportunity. It reduces the amount of drilling needed to find productive shale oil, which means less harm to the environment. Statistics show that fracking only recovers about 20% of the oil trapped in shale rocks. By assimilating vast amounts of different types of data, well log images, seismic readings, video image feeds, data from field sensors, drilling notes, and so on, big data techniques can assimilate that data into an integrated profile. That data can then be extrapolated to determine what is going to happen where and when. In oil exploration, that means determining where the best place is to drill. To accurately interpret seismic images, prescriptive analytics needs to combine data from different computing and scientific sources. For example, by combining machine learning, pattern recognition, and computer vision, algorithms can produce images to reveal where and how to drill. The where and how to drill is the prescriptive component. Beyond oil exploration, prescriptive analytics can model well performance and help companies understand where they'll get a certain amount of oil. Digitizing well logs creates depositional subsurface maps. This involves using data from well production, subsurface completion, and other sources. Prescriptive analytics also can model limitations related to fracking exploration. For example, a shortage of pressure pumping equipment and available labor can be modeled to assess the costs of drilling and production against return on investment. Prescriptive modeling is ideal for decision mapping, balancing current business demands and business objectives against constraints. Prescriptive analytics is also making oil production more efficient. For example, with many fracking operations, only a small portion of available shale oil is actually extracted. Using prescriptive analytics, you can make improvements that will make the next well more productive and cost-effective. For example, many shale producers are drilling unfinished wells because they have to drill to keep their lease, and a new lease could cost as much as 5 times more. Drilling is only 30% of well completion costs, where fracking is 70%, so prescriptive analytics can be used to model where to drill and when to maintain potentially productive land leases. More importantly, you can watch for unsafe drilling behavior and prevent potentially fatal accidents. 7. Travel and transportation optimization. The travel industry is an industry that sees a lot of potential in the latest edition of analytics. Online travel websites, such as airline ticketing services, hotel websites, or car rental websites, have turned to prescriptive analytics to sift through multiple complex iterations of travel factors, purchase and customer variables such as demographics and sociographics, demand levels, and other related data sources to optimize their pricing and sales. Other applications in the travel industry are segmenting potential customers based on multiple data sets to understand how to spend the marketing budget. More accurate targeting, of course, results in higher conversion rates, and to be able to make detailed segments, a lot of different variables are required. The Intercontinental Hotel Group, for example, uses 650 variables to determine the best price, product combination for the right customer. Another use case of prescriptive analytics is route optimization for the logistic industry. Universal Parcel Service, or UPS, is the best example of this. By analyzing and combining hundreds of data sources, UPS can push 10,000 route optimizations per minute to all of their trucks. This saves the company millions of dollars on fuel a year. UPS uses a wide variety of data to reduce the environmental impact of their business. They combine data from engines that provide UPS with insights in performance and condition of their vehicles. Apart from the engine performance, also speed, number of stops, mileage, and miles per gallon, etc. are measured. They use GPS data that captures driver behavior and safety habits. Sensors in vehicles report data on emissions and fuel consumptions. All kinds of devices monitor deliveries and customer services, as well as address points and routes traveled that can be analyzed to optimize the routing again. In addition, all drivers have state-of-the-art handheld devices that also collect a lot of data. Long story short, they collect data at every possible moment. Because of all the data they collect, UPS is capable of creating unique services for its customers. One of such services is My Choice, which allows customers to adjust delivery timing and location via the smartphone at any moment. But they also invest a lot of money to speed up the delivery process. As such, they have connected their systems with millions of their customers. This allows them to move the data ahead of packages and, for example, pre-clear packages before they arrive at U.S. Customs. Thus, international packages can be moved directly to domestic packages and be delivered the following day. Their latest project is called Orion and costs $1 billion a year. Orion stands for On-Road Integrated Optimization and Navigation. Orion uses fleet telematics and advanced algorithms to take route optimization to the next level. Started in 2013 and deployed across North American routes in 2017, Orion is viewed as the largest operations research project in the world. With 250 million data points, Orion is capable of delivering tens of thousands route optimizations per minute based on real-time information. Next to that, the system allows UPS managers to monitor driving habits of its workers and see when a driver backs up a truck too often or makes too many U-turns. This information could signal drivers that require additional training to become more efficient. 8. Weather forecasting. The amount of available data can be both a blessing and a curse. While it's important to have extensive data from many sources to gather accurate information and offer pointed predictions, it can be complicated to select which weather models are most applicable to the data at hand. In addition, the further into the future a forecast is made, such as a week out or even longer, variables such as the constantly changing atmosphere can complicate matters. This is why continuous, real-time analysis plays a crucial role in accurate weather forecasting. By incorporating tools from artificial intelligence and machine learning algorithms, it's possible to significantly increase the reliability of weather forecasts. Weather models can be made much more accurate by using these tools not only to quickly process huge amounts of weather data, but to offer a more refined approach the more the models are used. Data analysts who are trained to predict the weather offer many benefits to various stakeholders, from individuals to entire regions of a country. Weather analysts rely on various data analytic and predictive analytic techniques in order to provide the most accurate and helpful forecasting models possible. Accurate weather predictions have many real-world ramifications. They can help people decide on the best course of action to protect themselves, their products, and their belongings. By predicting what the weather will bring, lives can be saved. That ends our topic on the common business applications of data analytics across multiple industries. While we have considered many industries, the list is by no means exhaustive. A little research in the internet, and you will find other industries using data analytics, usually coupled with artificial intelligence to innovate their products, processes, or systems, leading to business transformation. In our next topic, we will look at 3 well-known brands that have done so: Coca-cola, Netflix, and Starbucks.
Real-life case studies. In this section of the chapter, we will look at some real-life examples of the application of prescriptive analytics applied in well-known companies like Coca-cola, Netflix, and Starbucks. The YouTube playlist on the slide will direct you to a wealth of case studies of how analytics improve the operations of big businesses and ultimately, their bottom line. The first case we will look at is Coca-cola's implementation of vending analytics, an artificial intelligence application developed by Hivery, a tech company specializing in unlocking data insights. Faced with declining vending machine revenue in Australia and an inability to leverage vast amounts of collected data, Coca-cola collaborated with Hivery to develop and deploy vending analytics. The core problem the AI solution addresses is how to stack a vending machine for maximum sale and reduce the time to revisit that vending machine. Coca-cola's initiative highlights a significant industry problem, an inability to leverage big data to improve the top and bottom line. Vending analytics learns over time by analyzing Coke's vast amounts of untapped data to make intelligent decisions regarding product assortment, pricing, and placement at an individual machine level. The following results of the AI implementation are highly impressive. 1. Enhanced efficiency and cost savings. The AI system significantly reduced the need for frequent restocking visits. Drivers aimed for machines to be as empty as possible but with no product selling out. The AI enabled this by optimizing inventory, allowing visits to be less frequent. Instead of the drivers going every 20 days to fill vending machines, they now go every 40 days. This directly leads to significant cost savings. 2. Granular, hyperlocal optimization. Beyond human capability, the AI's ability to make highly specific, counterintuitive decisions is a critical innovation. The system learned the individual trading behaviors of each machine and started seeing patterns and opportunities for a particular machine to drive better revenue through better product assortment as well as space or price opportunities. In hospitals, the AI recommended only one facing of the Monster energy drink instead of the usual 15 to 20 facings, because it concluded based on data that people visiting emergency rooms don't usually buy energy drinks. In stadiums, the AI allocated to rows in the machines to Minute Maid lemonade beverages because the machine was patronized by sports team or band crews who tend to drink a lot of lemonade. It was noted that this is unusual because no beverage driver would have allocated to rows of lemonade in the machine, highlighting the AI's superior, data-driven insights. 3. Streamlined operations and speed. The AI tool is described as one self-contained unit that is easy to use and makes more intelligent decisions faster. Previously, it was necessary to import data from different sources and use spreadsheets. The AI tool can generate a high-quality optimization planogram, a visual layout or diagram that shows exactly how products should be arranged inside the machine, into minutes compared to 20 minutes time taken by existing management software. It also performs what-if analysis for new products without physical testing. The AI implementation produced significant business impacts. Its initial pilot run in Amidale, Australia, increased Coca-Cola's revenue by 15% and reduced costs by 18%. Coca-Cola Amidale's company-wide deployment of the AI solution by the end of 2017 delivered 6% additional revenue and 15% fewer stocking trips. This demonstrates a clear return on investment through increased sales and reduced operational expenses. Coca-Cola's adoption of AI-driven vending analytics serves as a powerful case study for how intelligent systems can transform traditional business operations by leveraging previously untapped data. The company achieved significant improvements in both revenue generation and cost efficiency, demonstrating AI's capability to outperform human intuition in complex optimization tasks. This success holds substantial implications for other data-rich industries seeking to maximize profitability and operational efficiency.
The second case we will look at is Netflix's extensive use of data analytics and artificial intelligence to achieve its industry dominance and save $1 billion annually. As we have learned in Chapter 1, how was Netflix able to achieve these feats? Starting video streaming in 2007, Netflix rapidly grew to over 100 million subscribers by 2018. As of mid-2025, Netflix is estimated to have around 312.5 million paid subscribers globally. Netflix has revolutionized the entertainment industry by leveraging data analytics and artificial intelligence as core pillars of its strategy, intensely focused on understanding and retaining customers through data. Their innovations in data analytics, AI-driven content decisions, and proprietary content delivery networks, CDNs, have led to significant cost savings, an impressive 80% success rate for new shows, and a highly personalized user experience, with 75% of viewing driven by recommendations. Artificial intelligence plays a critical role in Netflix's content strategy, leading to substantial savings and improved decision-making. This strategy includes content spending decisions. Netflix's spending is mainly on artificial intelligence to make content spending decisions, which shows that AI saves $1 billion every year. Reduced human intervention. AI helps Netflix improve its algorithm and uses them to reduce the human intervention in programming decisions. Unlike traditional studios that rely on pilot episodes, Netflix uses data analytics to determine the likelihood of the show's success. This approach has resulted in an impressive success rate of Netflix shows, or 80%. Reduced promotional costs. By accurately predicting show success, Netflix can reduce the cost on promotional advertisements and campaign budgets. It does this in a twofold approach. 1. Understanding user needs. The recommendation system understands the need of the users and provides suggestion of the various cinematographic products based on their users' liking and preferences. It processes users' information as input, such as past usage of product or ratings, to predict user preference. 2. Improved personalization with ranking algorithms. Netflix continually refines its personalization through ranking algorithms to provide a ranked list of movies and TV shows. They use an interleaving technique to speed up the experimental process to identify the best ranking algorithm, providing enriched content that is highly sensitive towards ranking the algorithm quality. Netflix's journey from a DVD rental service to a global streaming giant is a masterclass in leveraging data and technology. By deeply understanding user preferences through advanced analytics, investing heavily in AI for content decisions, and continuously refining its recommendation algorithms, Netflix has built a highly personalized, cost-efficient, and dominant platform that continues to set the benchmark for disruptive innovation in the entertainment industry. Its success underscores the immense power of data-driven strategies in achieving competitive advantage and fostering rapid growth.
The last case we will look at is Starbucks' transformation into a data technology company for food and beverages, particularly after the 2008 financial crisis prompted a strategic shift. After the 2008 financial crisis, Starbucks faced a perfect storm of economic downturn, internal inefficiencies, and brand dilution that almost derailed the company. Here's the breakdown. 1. Sharp decline in sales and profits. The financial crisis caused customers to cut back on luxury purchases like $4 lattes. Same-store sales dropped for the first time in company history, and net income fell sharply, and stock value dropped more than 50% in 2008. 2. Overextension and cannibalization. Starbucks had grown too fast, from approximately 4,000 stores in 2000 to over 15,000 by 2007. Many locations were too close together, eating into each other's sales, and international expansion was uneven, with some markets underperforming. 3. Brand dilution. The brand's premium coffee experience image weakened, and many stores were focused on efficiency over atmosphere, eroding the third-place experience that made Starbucks special. 4. Operational inefficiencies. Costs per store were high due to waste, complex supply chains, and inconsistent service quality, and the menu had expanded to the point of slowing operations and losing focus on core coffee offerings. 5. Rising competition. McDonald's, McCafe, and Dunkin' Donuts expanded aggressively into specialty coffee, offering cheaper alternatives, and local artisan coffee shops started attracting more serious coffee drinkers. After deciding that data should be more analyzed and put to good use, Starbucks leveraged data analytics, using vast amounts of data, nearly 100 million transactions per week, artificial intelligence, AI, and the Internet of Things, IoT, to gain a competitive advantage. These methods include optimizing new store locations, making data-informed decisions about product development for in-store and grocery offerings, and enhancing customer loyalty and personalization through its mobile app and AI-powered recommendations. It also implemented digital signage for dynamic menu adjustments and the use of IoT in coffee machines for predictive maintenance, all demonstrating Starbucks' commitment to utilizing technology for continuous improvement and business excellence. The following are the main themes and key ideas behind Starbucks' technological transformation. 1. Data as the core of strategic decision-making. Prior to 2008, Starbucks, like many organizations, relied on experience and judgment. The financial crisis forced a paradigm shift, teaching former CEO Howard Schultz that data should be used more analytically. Starbucks is a pioneer in combining loyalty systems, payment cards, and mobile apps, demonstrating an early commitment to data collection for competitive edge. 2. Strategic location planning with data. The 2008 crisis necessitated closing hundreds of stores, prompting a more disciplined, data-driven approach to store openings. Today, Starbucks utilizes a powerful in-house solution named Atlas, a geographic information system, GIS, based market planning and business intelligence application, to determine where to open new stores. Before recommending a new store, Starbucks evaluates massive amounts of data, including variables such as population, income levels, traffic, competitor presence, and proximity to other Starbucks locations. This enables accurate forecasting of revenues, profits, and other aspects of economic performance. This data-driven approach is actively assisting in determining where the next 1,500-plus stores should be located. 3. Data-driven product development and market expansion. Starbucks heavily relies on gathered data to understand consumer preferences and determine which products to offer when launching new products, especially when expanding its product lines into grocery stores. Examples include 1. Launching a new product line of unsweetened iced teas after discovering 43% of tea drinkers avoid adding sugar. 2. Introducing a new line of black iced coffee without milk when data showed 25% of consumers do not add milk to their coffee. These enhancements are not just about customer satisfaction, but a market share grab strategy that's been hugely successful, bringing the retail brand into consumers' homes. 4. Hyper-personalized customer experience via the digital flywheel. The launch of Starbucks Rewards program and mobile app significantly increased data collection, allowing the company to get to know their customers and extract information about their purchasing habits. Starbucks uses the digital flywheel program, a cloud-based artificial intelligence engine capable of making precise food and beverage recommendations. This system allows the point of sale to identify the customer through their phone and give the barista their preferred order, even at new locations. The system could also suggest new products a customer might like based on their purchase history, as well as provide unique discounts and rewards on specific items based on their unique preferences. Starbucks goes one step further by collecting data on weather patterns and their relationship with customer order patterns, enabling promotions like delivering cold drinks to a customer on hot days. 5. Optimizing in-store operations and future innovations. To align with dynamic offerings, Starbucks is rolling out digital signage in stores with computer-generated menu displays. This completes a chain that allows changes in the customer experience to be reflected in the store. Starbucks is also able to predict equipment maintenance needs using AI and IoT because it recognizes that when a machine fails, it can have a significant impact on business performance. Its new coffee machine, Clover X, currently in flagship stores, is cloud-connected, enabling more comprehensive collection of operational data, remote fault diagnosis, and even remote repairs. Similar cloud connectivity is envisioned for other machines, moving beyond USB drive updates to direct cloud connection, opening up more AI opportunities. Starbucks' leverage on data analytics, AI, and IoT has brought the following outcomes. 1. Restored profitability and increased same-store sales. By 2010, Starbucks had returned to profitability and restored investor confidence, and reported a net income of approximately $946 million. Same-store sales rebounded, operating margins improved, and the company's stock price tripled from its 2008 low. By 2024, the company earned around $3.76 billion in net income, nearly 4 times the 2010 figures. The Starbucks Rewards program rapidly became one of the most successful retail loyalty platforms, boosting repeat visits and average spending per customer. 2. Rebuilt brand loyalty. Brand strength was restored, with customers once again associating Starbucks with quality coffee and a welcoming environment. Operational improvements reduced waste and costs, making the company more resilient. Product diversification into grocery and ready-to-drink channels created new revenue streams and extended the brand beyond its cafes. 3. Achieved a stock price recovery, more than tripled from the 2008 low within 3 years. In 2007, Starbucks traded around $8.35. By the end of 2008, the price plunged to approximately $3.86 amid the global financial crisis. 2010 saw a significant recovery, with the price rising to around $13.11, showing renewed investor confidence. 4. Positioned itself for sustained global growth, especially in China. Internationally, Starbucks emerged leaner and better positioned for growth, particularly in high-potential markets like China. The 2008 crisis ultimately served as a catalyst for transformation, enabling Starbucks to rebuild its foundations and set the stage for a decade of global expansion and sustained market leadership. Starbucks serves as a textbook example of how to start a journey to utilize data strategically, implementing plans systematically and thoroughly. The company's successful integration of new technologies, particularly data analytics, AI, and IoT, into its core business, demonstrates a continuous commitment to innovation. Starbucks' future trajectory is firmly rooted in leveraging ever-increasing data to provide an even more personalized customer experience and achieve business excellence, showcasing that adoption of technology was not a burning desire, but just a matter of doing it when the time was right. These case studies of Coca-cola, Netflix, and Starbucks collectively illustrate a powerful paradigm shift in business, strategy driven by data analytics and AI, from optimizing operational efficiencies and reducing costs to revolutionizing customer engagement and product development. These companies demonstrate that leveraging data is no longer an option, but a necessity for competitive advantage. The journey typically involves a proactive embrace of technology, a willingness to learn from crises, and a commitment to integrating technologies into core business processes, ultimately leading to significant revenue growth and enhanced customer loyalty. This also means that for data analytics implementation to be successful, and considering the massive investment in resources that needs to be infused into the project, entities must know the factors that would make their very own analytics endeavor a success. And that is the subject of our last topic, the pillars of successful prescriptive analytics.
The 5 pillars of prescriptive analytics success. These pillars are based on an article written by Atanu Basu, published online in pubsonline.informs.org. Atanu Basu is the CEO of Ayata, a pioneer in prescriptive analytics technology. Based in Austin, Texas, the company's customers include Fortune 500 operators in the oil and gas industry and in high tech. Ayata invented the technology behind prescriptive analytics with hybrid data, capitalizing on its over 10+ years of research in artificial intelligence and related disciplines. As the big data analytics space continues to evolve, one of the breakthrough technologies that businesses will be talking about in the coming years is prescriptive analytics. The promise of prescriptive analytics is certainly alluring. It enables decision makers to not only look into the future of their mission-critical processes and see the opportunities and issues that are potentially out there, but it also presents the best course of action to take advantage of that foresight in a timely manner. What should we look for in a prescriptive analytics solution to ensure it will deliver business value today and tomorrow? 1. Hybrid data. Most businesses today run on structured data, numbers, and categories. According to IBM and other tech companies, 80% to 90% of the data currently produced is unstructured: text, image, video, and audio. While some businesses may choose to run the same way in the future as they do today, doing so could render them unproductive and non-competitive. These businesses may not survive as their customers, suppliers, and competitors move beyond them by taking full advantage of hybrid data, a combination of unstructured and structured data. Hybrid data empowers businesses to use all the available data to make the best decisions possible. For a prescriptive analytics technology to be transformative, it must be able to process hybrid data without incorporating hybrid data. Decision makers are making their decisions based on just 10 to 20% of the available data. The figure on the slide is a chart from Gartner research that showcases the evolution of analytics, culminating in prescriptive analytics with hybrid data. Processing of hybrid data brings into the mix new technologies that are essential ingredients in prescriptive analytics software, including computer vision, speech recognition, image processing, natural language processing, signal processing, and more. While traditional disciplines such as applied statistics remain invaluable, they aren't designed to process image, video, audio, and text. 2. Integrated prediction and prescription. Prescriptive analytics is about seeing and then shaping the future. Common sense tells us that one needs to first see the future before one can shape it. The functions of predictions and prescriptions must work synergistically for prescriptive analytics to deliver on its promise. The symbiotic integration of predictions and prescriptions is the key to widespread adoption and inherent value of prescriptive analytics. Assume a scenario where predictions and prescriptions are coming from two different systems that have been cobbled together. Easier said than done, but let's ignore that for now. Say this software combo produced a prescription that turned out to be Faulty. If this is a software issue, is this error due to a bug in the prediction software, or the prescription software, or both? Imagine the disruption to your business as you investigate the root cause and attempt to preempt similar erroneous prescriptions in future. 3. Prescription and side effects. Prescriptions, i.e., recommended, time-dependent actions to improve the future. In prescriptive analytics, technology are generated using several methods. A prevalent method of coming up with prescriptions is through a guided framework of business rules. This rule framework can be simple or complex, depending on the business process or the initiative that is being governed by prescriptive analytics. A more scientific and rigorous way to produce prescriptions to improve the future is through operations research, or OR, the science of data-driven decision-making. OR takes into account the objectives, the constraints, and the actionable knobs, known as decision variables, to produce the best course of action, a prescription that doesn't lead to undesirable side effects. Both optimization and simulation technologies, two prominent branches within OR, can be used to generate effective prescriptions for a prescriptive analytics technology to scale. The solution should use both business rules and operations research and use them synergistically. Then and only then can this technology be able to generate the most effective and timely prescriptions that the available data will allow. 4. Adaptive algorithms. Imagine you are driving to work. As you drive, what you see ahead through your windshield keeps changing, and what you do based on what you see ahead, and when you see it ahead, also keeps changing. In our daily lives, we find this reality to be an obvious one, and we do the needful without much thought. Now think about a business process that you are trying to improve through prescriptive analytics technology. As this business process evolves over time, the technology should continually re-predict and re-prescribe so the predictions and prescriptions remain relevant. In a world of growing data volume, velocity, and variety, the prescriptive analytics technology must be able to automatically recalibrate all its built-in algorithms, plus automatically create new algorithms. Recalibration of the algorithms in the prescriptive analytics software can be triggered in several ways, with new data arrival, with data changes after a specified time period, and more. Another important factor to keep in mind is the actionability of the prescriptions. It is, of course, different for different business processes. Sometimes, it may not be helpful to automatically generate newer prescriptions if the old ones haven't been acted upon properly. 5. Feedback mechanism. How would the prescriptive analytics software know if its prescriptions are being acted upon? Prescriptions are, generally speaking, time-sensitive action plans involving changes to some actionable influencers to preempt one or more predicted issues, or to benefit from one or more predicted opportunities. If a business manager decides to ignore a prescription from the software, this inaction would at some point be reflected in the incoming data that is being collected on the actionable influencers. The consequence of inaction, if any, will then be subsequently reflected in the upcoming predictions and prescriptions. For example, due to lost time, inaction on a valid prescription could lead to additional expenses in preempting an upcoming issue that has been flagged by a prediction and addressed by a prescription in the last round. While this may change in the near future, today, there is a difference between prescriptive analytics software and prescriptive automation. Prescriptive automation, Google Car, for example, has elaborate, built-in process control software, hardware, firmware, and much more to automatically action the prescriptions coming from the software side. Prescriptive analytics software today still requires human assistance to carry out these prescriptions, while Google can probably outfit a car any way it wants to. Companies with highly sophisticated prescriptive analytics software are dependent on humans to act on the prescriptions coming out of the software. Envision a future where this distinction would disappear, and prescriptive analytics software will become a fully integrated and embedded component of the business process it is improving, and not the new thing that it is today.
There it is, Chapter 2, Business Application and Pillars of Prescription Analytics. In summary, this chapter has shown that prescriptive analytics is not just a theoretical concept, but a powerful tool with wide-ranging applications in business and beyond, especially when combined with other technologies like AI and IoT. By examining its common areas of application, we see how it drives efficiency, innovation, and informed decision-making in diverse fields. Through case studies, we have connected theory to practice, revealing how real organizations harness prescriptive analytics to overcome challenges and seize opportunities. Finally, by understanding the 5 pillars of prescriptive analytics, we have established a solid framework for building and applying solutions that are data-driven, optimized, and actionable. Together, these insights underscore the transformative role prescriptive analytics plays in guiding businesses toward the best possible outcomes. On the slide are the references used in making this lecture video. Thank you for watching and stay safe always.